Okay, good morning, one and all. So, this is going to be the last session in control systems. Today, I'm going to show you a few of the things about the lab, how it to be carried out. So, we have seen so far different numericals on control systems related to state variable analysis. So, all these notes, what is the definition of state, what is the definition of state variable, all those things were discussed earlier. Then this is a numerical that we had seen, that is if a second order RLC circuit is given, then how to find out the state space representation. So in that case, you have to define what is output matrix, what are the state variables. So this is a numerical which was seen. After that, the same numerical we had solved for three different output equations, and that was the first part. Second part, we had seen what is the transfer function, how to find out transfer function from state space. So ABCD matrix were given, from there C into Si minus A inverse into B plus D we had done. We had got what is the transfer function from the state variable representation. So many numericals we had done. So this is another numerical. It is being recorded, so it will be uploaded. So you are finding that A matrix is given as 1011. This was a numerical which was asked 2 years back in the exam. C matrix is given, B matrix is given, D matrix is supposed to be 0, and you are asked to find out what is the transfer function. So very simple numerical, there is nothing special in this, but you have to do all this transfer function finding and finding the state variables, all those things you have to do by using a small, very small command in MATLAB. Okay, so I'll be showing you some commands in MATLAB, and afterwards, when I formulate this questionnaire for experiment number 9, this is going to be your last experiment. So, experiment number 8 on board upload, it was uploaded 2 days back. Tomorrow, 31st, or I think 2nd of August is the submission deadline for that. This experiment also will be formulated, code and all will be given to you. So what you have to do is you just have to execute few of the transfer functions and few of the state variables that is already asked. So I will tell you in detail exactly what is to be done when I define and upload the document for experiment number 9. So mainly there are two things, that is transfer function to state variable and state variable to transfer function. So there are commands for that. So TS to SS, TF to SS, and SS to TF2. SS stands for state variable or state space, and TF stands for transfer function. So if transfer function given, you are supposed to find out state space. It is called as TF2 numeric to SS. And if state space is given, you are supposed to convert it to transfer function. It is called SS to TF. So all those things we will see today only, and if the bandwidth permits, I will show you some of the state space related MATLAB functions and codings, and some standard some small codes we can do from TF to SS and SS to TF. So this is officially is going to be the last lecture for your whole syllabus, but yes, our discussion and all these things will keep on going. And what I hear is from ninth onwards, students are expected in campus. So if they, we will do this, we will extend actually this experiment in the on 9th August onwards, because transfer function, state variable, and system model to transfer function and simulink, all those things are having huge scope. Okay, so today in this 45 minutes lecture, I'll not be able to complete everything, but lot of things can be done in state variable analysis using MATLAB. So all those things I will try to formulate. I'll try to create a document with all those things that we can do by using a MATLAB. How can we solve state space, and how can we find all the solution of state space, and how can we plot it, all those things. I'll upload it. So just as a glimpse, you can see here that ABCD matrix is given, and we know how to find the transfer C into Si minus A inverse into B plus D. So this is hand calculation, it is done. So A matrix is given as 1 0 1 1. First we have to find out Si minus A. So this is Si, that is, this is a second order identity matrix. Okay, so this is Si, that is S00S minus A, and then you have to find out Si minus A and determinant of that. So determinant of Si minus A and determinant of Si minus A inverse, both are same. So even if you are taking the inverse, it does not change the determinant. Okay, so Si minus A inverse I have found 1 by delta adjoint of Si minus A. All those steps are done. And after that, partial fraction and all these things are done. Sorry, not partial fraction, sorry. Inverse of Si minus A is done. And Cs by Rs. So Cs by Rs is nothing but C into Si minus A inverse into B. Okay, plus D is not there. So that's why transfer function we are finding as 1 by S minus 1. So this is a transfer function of a first order system, because Cs by Rs is the transfer function of a closed loop system, and we are finding that it's an unstable closed loop system. How do we know that? Because denominator equation is S minus 1, and that means S minus 1 is equal to 0. That means whatever uh, pole I am finding, that pole actually is lying in the right hand side of S plane. So again, I'll tell you this 1 by S minus 1, that is a CS by RS, that has come from C into Si minus A inverse into B plus D. And this is actually an unstable closed loop transfer function, because S minus 1 is equal to 0, S is equal to 1. That means e raised to t, that will be the value of Ct in impulse response. And we know that if poles are in the right side of S plane, it is going to be a unstable pole. So this is going to be an unstable pole, and this is an unstable system. Now, how to develop, okay, the MATLAB code to find the system transfer function for given system and vice versa? Generally, num and den. Okay, so these two are the abbreviations that you have to understand. It is in S domain. So we have seen S is equal to TF of S. So at the starting of every GSHS, that is in Bode plot, in root locus, we have done that step. That is S is equal to TF of S. So TF is a function. So first we define what is S. So S is actually the whole transfer function is given in S. So that is the meaning of S is equal to TF in S. And transfer function, you can define anything. So here I have defined a transfer function which is proper. Okay, that is 10s plus 10 divided by s cube plus 6s square plus 5s plus 10. Generally, you try to keep order of the numerator less than the order of the denominator. So this is a closed loop transfer function. We can find the state variables for A, B, C, D matrices from given ys by us. Okay, so this is a transfer function given, and from the transfer function you are going back to ABCD matrix. So that is actually the reverse process. What did we do there? From transfer function we tried to find out the companion form. Now here we are finding that it is the characteristic equation is s cube plus 6s square plus 5s plus 10. That means there will be three integrators in the central line, and top there are actually three amplifiers, bottom also there are three amplifiers. All those things we have seen. So top part is the input part, bottom part is the feedback path. Feedback is coming from the output, and always we know that yt is equal to q1t, where q is the first state variable. So all those things we know, and this kind of numerical also we have solved. So you understand that, and that will be enough. So 10s plus 10. So in the numerator we'll be finding that there are two coefficients. One is 10, another is 10. So s square and s cube terms are not there in the numerator. So if you are drawing the companion form, you will be finding that at the top portion there will come two multipliers, and at the bottom there will come three multipliers, and all the multipliers will be having gain as minus 10, minus 5, and minus 6. Because this is something you had to see, because it's a positive negative feedback system, I'm sorry. That's why all this gains whatever are coming, okay, that is the amplifier gains, that will be minus 10, minus 5, and minus 6. So minus 10 will appear in the left side, then minus 5, then minus 6, like that. Or you can check what is exactly that there. So that is not a problem. Now we are actually seeing how to develop a MATLAB code for the given system. So command to convert the transfer function. So transfer function is shown as TF. So this is a lecture, but actually I am doing a lab session, and only few commands I will show. More commands I will make some smaller modules. I will put them into a document and I'll upload. I will try to upload that thing by today itself. So today only I will define the experiment and your work for experiment number 9. It will not be big, okay, only 4 5 different transfer function or state variables and all those things I would ask you. But main thing is you have to learn how to solve state variable by using MATLAB, how to convert transfer function into state variable, how to convert state space model into transfer function. So likewise, some 4 5 different things I will define, and I'll prepare the document. So first, what I'm showing you is how to convert ABCD matrix is expected. That means if transfer function is given, okay, so numerator and denominator both are given. You can find here y is equal to ys by vs is num by den. Okay, so numerator polynomial in S, denominator polynomial in S. This thing is given. I want to get ABCD matrix for that. So what you do is ABCD is equal to TF2SS. TF2SS is a command. Okay, so when we open MATLAB shortly, I will do that shortly. We will see what is the structure of TF2SS and SS2TF. So these are the two main commands. One is tf2ss, that is the transfer function is given. We want to find out ABCD matrix, that is the state space representation. And second is state space representation is given. I want to find transfer function. Once you find transfer function, in that case, just do the cross multiplication and take the inverse Laplace transform. You can find what is the system differential equation. So four things I told you, they are actually intertwined. First is a differential equation is given to you, second order, third order, whatever. And what is the first step? You take the Laplace transform. So you find the equation in ys, you find the equation in xs. Then you find ys by xs. So you just do the arrange the coefficients so that you find ys by xs. So that is from system equation, that is a system differential equation. You are finding what is the system transfer function. That is the first job. As soon as you are finding the transfer function, second job is to convert that thing into companion form. How to do that? 2 3 numericals we have solved. So from differential equation to transfer function, from transfer function to companion form. After you are finding companion form, for every integrator you have to find the equation. So you can find equation of q1 dot, you can find equation of q2 dot and q3 dot, and you will be finding the state variable equations. Then you have to write q1 dot, q2 dot, q3 dot in a vector form is equal to A matrix, then q1, q2, q3 plus B matrix ut. Okay, so if there is only one input, then this B matrix is going to have 3 cross 1, because in this case you will be finding there are 3 state variables. How do I know there are 3 state variables? Because you can see here whatever transfer function you are finding, that thing is having denominator equation in S cube. Okay, that means whatever transfer function we are going to find, that will be having 3 order equation in the denominator. That means if you are finding the state variable, there will be 3 state variables, q1 dot, q2 dot, q3 dot, likewise. And if you are solving that, obviously you have to solve the non-homogeneous system, then you will be getting 3 equations. Equation in q1, equation in q2, equation in q3. And you have to plot all those 3 things, q1, q2, q3. So what I will ask you in this experiment number 9, I will first give you a system equation, okay, and then I will ask you find transfer function from that. From transfer function, I'll ask you find state variable of that. After you have found out state variable, then I'll ask you find out what is the solution of state variable. So state variable is actually model is given as q dot is equal to a qt plus but. What is meant by solution of state variable? You have to find the equation of qt. If qt is having 3 third order, that means you have to find out what is the equation of q1t, what is the equation of q2t, what is the equation of q3t, and then you have to plot it, q1, q2, q3. All these 3 things you have to plot in 3 plots with some time. So maybe 0 to 5 seconds, 0 to 10 seconds and all. So this is the execution of the experiment. All the codes are very small, 4 5 6 line codes. It will be given to you. So command to convert transfer function into state space or state variable form. So state space means state variable form. It is given as SS. So SS means state variable form. So what is the command? ABCD is equal to TF2SS num comma den. So before that, you have to actually find out, or you have to represent the transfer function. Transfer function, one example is given at the top, that is 10s plus 10 divided by s cube 6 square 5s 10. So this actually you have to first form by using num and den formula, and then only you can write down this ABCD is equal to TF2SS num and den. It will give state space representation for the system given by transfer function ys by us. The state space representation is not unique. Okay, there may be many, actually infinite number of state variable representation or state space representation. So for the same system, code for the transfer function to state space. So I've given you first a transfer function. I asked you to find out what is the state space. So here the code is given. So CLC close all clear all, S is equal to TF of S, and G is equal to 10S plus 10, and then S cube 6S square 5S plus 10. So whenever you are writing in the MATLAB form, this symbols you have to use like this. And finally you have to write the equation as ABCD is equal to TF to SS num comma den. Okay, I just tried writing this equation, but because of internet problem and all, I could not enter the whole code. So today again, I will try it shortly with you people logged in. We will see that. Okay. So after you are executing this, so how to do it is one thing. So after you're executing it, what you're getting is A, B, C, D matrix. Okay, so what you're finding is A matrix is a 3 cross 3 matrix. It was known actually because whatever transfer function we had given, it was in S cube. Okay, that's why A matrix would be a 3 cross 3 matrix. Okay, and you can do the eigenvalue decomposition of that. So a lot of things come after this by using ABCD matrix. There is something called a similarity transform we can do. The same system we can represent by a different set of ABCD matrix, but it will be representing the same system. That is whatever is given, 10s plus 10 divided by s cube plus 6s square plus 5s plus 10, whatever. Okay, but in that case ABCD matrix will be different. So converting this ABCD matrix into another set of ABCD matrix, it is possible because we told you that the representation is infinite. So state variable representation for the same transfer function, it can be having infinite number of ABCD matrix. It depends on what? It depends on the similarity transform. So it is not there in your syllabus, but jaan ke rakho, future sometime we will see that. Okay, so by similarity transform, you can find out A1, B1, C1, D1, which will be representing the same system given as 10s plus 10 divided by s cube and all. Okay, so that is one thing. You can find the, for finding similarity transform, first you have to find what is the eigenvalue, what is the eigenvector, and from there is a very small simple process. You can find out what is similarity transform. It's not there in your syllabus, just from mathematical point of view I'm telling. Another type of output. Okay, so you are finding that in this case we have changed the row. So here in this case -6 -5 -10, so 1 0 0 0 1 0. Or another representation can be you just exchange the rows, that is 0 1 0 0 0 1 and -10 -5 -6. So all these things are possible. So that's why they are saying that there are different types of state variable representation and it's never unique. Okay, so in this case, in the previous case of representation, you are finding B matrix is 1 0 0 and C is equal to 0 10 10. Okay, there is another representation where you are finding B matrix is 0 10 -50 and C matrix is 1 0 0. So one thing I had told you, what is called as companion form. Now companion form is actually converting the transfer function into state variables. Okay, and there is something which is called as canonical form. Okay, so canonical form 1, canonical form 2, all those things are there. So here at the top, actually they have shown canonical form 1 representation of A matrix, canonical form 2 representation of A matrix. So both the things are shown in this solution and next solution. But everything said and done, canonical form 1, canonical form 2, both can be found out directly from transfer function. And from the same transfer function, we can find out different canonical forms or different state variable representation of the system. So all these are actually not there in your exam. Anyway, you are not having exam. Just I have got time and you are also there. So I'm just trying to give you a higher understanding. So only thing is that state variable representation can be of various types. Okay, so there is not a single method or there is not a single representation of state variable. It can be of various types. So that was the first case when state variable was given or state space representation was given. Transfer function was given and we were finding the state variable representation. So what is the what was the command in that case? It was tf2ss. Okay, so far in the A category, or there are actually two parts of this whatever code I am showing you. So A part is command to convert the transfer function into state space or state variable. In the second part, we will see what? In the second part, we will see how to convert a state space. That is, if ABCD is given, then how to convert that into a transfer function. So the syntax to obtain transfer function from state space equation is numerator denominator is equal to SS to TF. SS means state space, to TF stands for transfer function. So in that case, it is ABCD. So SS to TF ABCD. So ABCD should be given actually. Okay. Then only you can find out what is the transfer function. So num den SS to TF ABCD 1. Okay. So what is 1? I will again tell you. Actually, this is the coefficient of highest order of S in the denominator. I think that is that. Okay. So there are 5 parameters actually here in the actual coding. That is A, B, C, D, and 1. So code for given state space to transfer function through MATLAB. So I have given you a ABCD representation. So this is a matrix, this is a B matrix, this is a C matrix, and then I am asking you that convert this ABCD matrix. So D matrix is not given, means you have to assume that D matrix is equal to 0. So code to convert the state space ABCD matrices into the transfer function. So percentage convert state space model into transfer function. Then I am saying that this is the A matrix. So you should know how to enter a matrix in a code. So you can read A matrix from somewhere, or you can input what is the A matrix. So in the first stage, we have converted our transfer function into a state variable. So the same state variables you can input here, and you can get the same transfer function at the output of this stage. So that can be one exercise. So A matrix is 0 1 0 0 0 1 and something is given. So this is actually a canonical form 1. Then B matrix is also given, C matrix is also given, D matrix is also given. And what is the code? Code is num den is equal to SS to TF A, B, C, D. Okay. That means you are actually converting the ABCD matrix into transfer function. That's why it is called as SS to TF. And what kind of transfer function you are going to get? You actually get the coefficients of transfer function. So what is the coefficient of transfer function? Num 0, num again 0. So this 0 is first 0 is actually, so this is for the numerator, and denominator you are finding this 4. Fourth thing is you have to start counting from left, sorry, right. This is actually the constant. Okay, this is 25.1026 into S plus 5.008 plus 5.0325 S square plus S cube. Okay, how do we understand this? Because here this 1, okay, whatever 1 is there, that is actually giving the coefficient of highest order of S in the denominator. So whatever S was written previously, whatever 1 was written previously here, okay, whatever 1 was written in the code, I'll tell you. So this one, whatever 1 is written after num den, whatever 1 is written, that actually will give us the coefficient of highest order of S in the denominator, that will be having equal to coefficient of 1. So that is this coefficient. So in this case, numerator transfer function is not given directly in the transfer function form, but transfer function is given in coefficient form. So this is the way you have to understand that. So numerator equation is actually 25.04 S plus 5.0080, and denominator equation is S cube plus 5.0325 S square plus 25.1026 S plus 5. Okay, so same result can be obtained by using command num den is equal to SS to TF ABCD is equal to 1. Likewise, so num den means y by us. So whatever are the coefficients given, whatever are the coefficients we have found out from SS to TF, from there whatever numerator and denominator coefficients you are finding out, with that you can find out this transfer function. So instructions for any given state variable model execute the same code with different set of ABCD. So this you can do. So 2-3 different codes you can take. So what I suggest you is I will define some ODE. I will define some ordinary differential equation. Okay, so from there you have to do the cross multiplication after taking Laplace transform, and you will be getting what is the transfer function. So from the transfer function, you have to execute that by using this code, very small code of 4 line, and get what are the ABCD matrix. So this is one set of exercise. Second set of exercises, the same ABCD matrix you can take, and again you do inverse. That is, ABCD is given, and from there you have to go back to transfer function. And as soon as you can find transfer function, you can find the actual system matrix in ODE from there. So this is one set of exercise that you will be doing in this MATLAB based state variable analysis. So this is a one set of experiment. Second set of experiment I will be showing you when I send the document to you. Okay, so in that what we'll do is we'll find the solution of a state variable. So ABCD matrix will be given to you, and I'll be asking you that find what is the solution of state variable. That means if A matrix is 2 by 2, that means there are two state variables. In that case, you will be finding what is the equation of a state variable 1 x1t is equal to some equation in time domain, and what is the equation of x2t, some equation in time domain. And actually you have to plot the x1t and x2t with respect to time. So that will be your second set of experiment. Okay, so these two experiments I'm defining. I will define the questions and I'll upload the document. Write what as the output of the code. So get transfer function from the state variable, again the same question. So these all are the questions I have assorted. So these were the numericals. Here you'll be finding this is a critically so there were three types of transfer function. One is when numerator is equal to the denominator. So this is the case, numerator order and denominator order are same. So this is called as a strictly proper transfer function. Proper transfer function is numerator order is less, denominator order is more. And improper transfer function is numerator order is maybe 3 and denominator order is 2. So for all those cases, you try to find out what is the state variable model, and you have to do the analysis and you have to tell me the output. So three cases we will do. One is proper, strictly proper, and improper. For all these three transfer functions, we will find out what are the state variable representations. Okay, so this is the work that I have cut out for you. Let us just try in MATLAB what it is given. Okay, so I tried this code. There was coming some error and all. I will rectify it and I'll post it to you. Don't worry. Let us go to the functions. Anybody can you reply if this window is visible? This
Yes,
MATLAB.
sir.
Okay, so let us just first go this thing. So SS2TF. Okay, so let us see what is meant by SS2TF. So let us see some of the functions and okay, so just see SS to TF, and again below you are finding TF to SS, both are given. Small codes are given here, so you won't have to depend on me. Directly you can come to this and you can find out. Okay, so just see that BA, it is given BA and is equal to SS to TF. That means state variable is given and sorry, state variable is given and you have to find the transfer function. So BA, what is B and what is A, we know. So there will come a numerator, there will come a denominator. So this function, if you give, it will come here. Okay, so they are finding something. And after that, they have found out u is equal to 0 to 1 minus n. I think they have found out the solution for that. Stem, okay, whatever output you are finding here, so in plot command also there are many things. So I'm deviating a little bit from state variable. Just see many types of plot command, and to you will understand a lot of things. I think you have done the MATLAB courses, so you know what is meant by stem, what is meant by bar. Okay, and there are many types of 3D plot commands that also you should check. Okay, so plot command itself is a very big important thing, so you should check that. Okay, so BA SS2 TF ABCD एक बार करके देखते हैं. Okay, so whatever is given, let us just do this BA and state space. So here I will write it, BA is equal to SS2 TF ABCD. So let us, so SS means there is, okay, like this. So let us define what is A matrix. So A matrix, let us define.
Sir,
Yes,
your display in MATLAB window.
is not visible.
No, sir. The PDF is visible.
Okay, correct. I'm sorry. I'm sorry. I will display my MATLAB window. Just one sec. So you open your MATLAB and I will display my entire screen. Allow. MATLAB window is visible.
Yes, yes.
Okay. So I'm sorry. I'm very sorry. So what you do is you first type here you are. So, I think it is visible, right? Command window and current folder and all those things. So at the top you write SS2TF. एस एस टू टी एफ, मेरे मेरे साइड में इंटरनेट थोड़ा स्लो है, सो just give me some time, but at your side if internet is moving fast, just write ss to tf and enter. And if you're doing this enter, what you will find is this kind of window. Okay, so here all those things will be very clearly visible. ss to tf, so all uh, the state variable related some commands, okay, all those things you are finding here. So use ss2tf and ss2tf function, all those things are given. So click on this first, that is ss2tf. What is ss2tf? State variable is given, abcd matrix is given, and we want to find what is the transfer function. So this b and a, I think this b and a are numerator and denominator. So let us just find out what it is. Okay, so I have one sec. Okay, so I have copied this command, and now I will define ABCD matrix. So A matrix I will define as, suppose, 1, 0 and minus 2, minus 3. So this is A matrix. Then B matrix you define B matrix, and everything should be capital. So B matrix should be in column form. Okay, so B matrix is 0, comma 1. This is how I'm defining. Okay, now C matrix is, so dimensions are very important. C matrix is 1 comma, let's say, minus 9. So you can check here, you should never make mistake, and D matrix is equal to 0. So now how to define ABCD matrix, this is a very important thing. And then what I will do is B comma A is equal to ABCD. Okay, now you have got it. So go very slow, because just now we have introduced this functions and we are finding out. So A matrix I have defined as 1, 0, minus 2, minus 3. So you know how to define the matrix. So this 1, 0 is the first row. So between these two elements, that is first column element and second column element, you should give a gap. Okay, so 1 gap 0, this is what I have given, then semicolon, and minus 2 gap minus 3. So if you do that, if you enter, you are getting A matrix as 1, 0 as the first row, minus 2, minus 3 as the second row. Then B matrix I have entered as 0 and 1. Okay, so B matrix is entered as 0 and 1, and this is a column matrix, that is very important. And then C matrix I am entering as 1 comma minus 9. Okay, so 1 comma minus 9 is the C matrix, and D matrix is actually I have defined as 0. So A, B, 0, 1, C matrix is 1 and minus 9, and D matrix is equal to 0. So what is CS by RS? Okay, so whatever B and A they have said, you can check the command, what command I have used. Okay, so this is the command, this is the command. I will just mark it with this. Okay, so this is the command. When ss is given, that is the state variable is given, at that time I want to convert it into transfer function. And what you have got, 0 minus 9, 9. Can you tell me what is meant by 0 minus 9, 9, and what is 1, 2 minus 3? So 1, 2 minus 3 means s square plus 2s minus 3, that is the denominator. Okay, so if you again see b comma a, b comma a is nothing but numerator comma denominator. So numerator coefficient and denominator coefficients will be found out if ABCD matrix is given in the code. Okay, so b comma a is equal to ss to tf. That means if transfer function is to be found out from ss, that is state variable ABCD matrix, then this is what you have to use. Any doubt in this? So 0 minus 9, 9 means this is minus 9s plus 9. So numerator equation is minus 9s plus 9, and denominator equation is s square plus 2s minus 3. Okay, so now all these things you can put in some kind of a code. So code the way I was writing it, actually I was writing a different code. I was writing a code for ulta. That means if a transfer function is given, I wanted to find out state variable, so I made a mistake. So is this code understood? So what you do now is you now just define something else. Okay, so this is CLC. So let us do this thing by using command window only, because this will be easier for us. So now I'll define A is equal to, suppose the same thing. Uh, so A is equal to, let's say 0 and 2, and this thing -3 and -4. Okay. Then B matrix is equal to, so let us define a two-dimensional B matrix and two-dimensional C matrix. Okay, let all the matrix be two-dimensional, like this, because all this we could not do in D matrix is also two-dimensional. So there are two inputs and two outputs. So this kind of numerical we have not done, like this. Are you following? So all ABCD matrix, all are actually two-dimensional. At that time, I have to do the same code. That is, so what I'm trying to show you is, if this kind of things are there, then what kind of transfer function we get. Dekho. Okay, so what we have, so it must be, IU must be specified for system with more than one input. I think some mistake is, so A matrix like this, B matrix like this, C matrix like this, and suppose D matrix is 0. Then if we try to find A or B comma A, C and D matrix, okay. So let us go, then let's say B is equal to, so let us come back to our original thing. C matrix is equal to 2 comma 0, and D matrix is equal to, so here let us define D matrix, let us say 5. And then, so previous case, when we got it, we put D matrix as, just check, okay. Can you tell me the difference between previous execution and this execution? Can anybody? So previous case we had put A matrix as 1 0 minus 2 3. That was the two-dimensional. B matrix we had put as a column matrix, that is 0 1. C matrix we had put at 1 and -9. Same thing we have done here. Okay, so A matrix is 2 by 2, B matrix is 2 cross 1, C matrix is 1 cross 2. But what is the difference here is, previous case we had put D matrix as 0. Okay, and now we have put as D matrix as 5. What was the result in the previous case when D matrix was 0? In that case, the result was -9s plus 9 divided by a square plus 2s minus 3. But in this case, can anybody tell me what is the transfer function? Just look at the result and tell me what is the transfer function. Hello? Anybody there? Okay, so in this case, we have found out A and B matrix. So whatever transfer function we are finding is, this is 5s square plus 24s plus 58. So B matrix gives you actually the coefficient of the numerator, and denominator coefficients are given as a square plus 4s plus 6. Okay, so again I'll repeat, numerator coefficients are given as, so num comma den, here instead of B comma A you can say as num comma den. Okay, and so numerator coefficients are 5, 24 and 58. That means 58 plus 24 is plus 5s square, and denominator coefficients are a square plus 4s plus 6. So this is a strictly proper transfer function what we are finding. Okay, so how it has become strictly proper? because this D matrix is here. So what is D matrix actually is doing is D matrix is making the system strictly proper. So this is something you have to understand, that when D matrix is there at that time, the order of the numerator and order of the denominator, they are becoming kind of a same. So this was SS to TF. Now what you do is TF to SS. So now just reverse thing we do, and what we will do is our state variable representation is given. From there we want to go to transfer function. So how to get that? So let us see what are the suggestions. So just see here, ABCD is equal to TF to SS B comma A. Okay. So how to write B comma A, that also should be given to us. So in this case, this kind of numericals are given actually. So you can just follow it, and you can find out how to give B comma A and how to get the functions. So here you can find out that ABCD is equal to TF to SS BF AF. So in this case, B and A are given. So B and A are two arrays that you have to define, as we have found in the previous case. So in this case, MATLAB, you are finding B and A as two arrays. So like this. So exactly the same way you define what is B, what is A, and then find out what is the transfer function, and from there you just say what is the value of transfer function from B and A. So let us just give a try. I just see whether we can go back or not. So B and A is given, and then what we do is we use the same code. We use the same code, and what is the code? That ABCD is equal to. Uh, so the same code we are using here. ABCD is equal to B comma A and TF to SS. So let us see what we get. Okay, so you can check here. Now whatever B and A is given, you have to define like that. So B is a B is an array actually of 5, 24, and 58, and A is another array of 1, 4, and 6. And if you are just writing TF to SS BA is equal to ABCD, in that case it will be giving you what is A matrix, B matrix, C matrix, and D matrix. Now the problem is, whatever ABCD matrix you had defined previously, A matrix was 0, 2, minus 3, minus 4. B matrix was 2, 3. Okay, C matrix was 2, 0, and D matrix was 5. Now when with that you converted that thing into transfer function, you got 5, 24, and 58, and A was 1, 4, and 6. Now you have done the reverse process. Okay, now suppose with this B and A, if you're trying to find out what is ABCD, you are finding that the ABCD matrix are different. Okay. So this is happening, but D matrix is same. C matrix and A B matrix, they have changed. A B C, all the matrix have changed. So previously you had found out ABC matrix as something else, like this, and D matrix was 5. In this case also D matrix is 5, but ABC matrix have changed. Okay, so this kind of thing can happen. It is because of similarity transform. And one very good thing is you are finding that D matrix is same for both the cases. In this case, B has become 1, 0, and C has become 4 and 28. That means the output parameters have changed. So all those things has happened. So you do this kind of things, and you will be finding it is very fun. So two functions I have actually taught you. One is TF to SS, and another is SS to TF2. Sorry, TF to SS and SS to TF, like this, these two equations. And ABCD is equal to TF to SS. BA converts a continuous time or discrete time. Discrete time is also there. We are doing all continuous time system only, but discrete time can also be done. So here, this is how you are supposed to define. So this numerical, let us do. Okay. So what we are getting, B and A, all these things are given. So things are actually very easy, like this. Okay, so B is equal to 0, 2, 3, 1, 2, 1, likewise, and then you are trying to find out like this. So you have actually defined the equation. So B is actually 0, 2, 3, 1, 2, 1, and A is equal to 1, 0.5, and 1. So two cases you have defined. So now you are finding ABCD matrix. Okay, so ABCD, A is 2 by 2, B is 1 comma 0, C is so in this case actually you are finding that there are two output equations, only one input and two output equations, because C matrix you are finding as 2 cross 2. Okay, so that's why there are two output equations. That's why B matrix is also having instead of one, okay, instead of one, it is having two rows. So be careful. So this kind of question is a little tricky. And D matrix is also 0 and 1. So this kind of thing happens. So if you are increasing the input to double, then also you will be finding B matrix also will become 2 by 2. Likewise. Okay, so such many cases are there. In this case, whatever result I have shown you, the same result is found here in command window. Okay, so same very different things are there. Here you can find out what is HS. Okay, so this is a typical case I'm showing you. If you just check this, there TF2SS or SS2TF. Okay, likewise. So these two commands only you have to do, and I will define this numerical and I will send it to you. So whatever we have covered so far in state variable analysis, only on the first part, that is converting the ABCD into transfer function or converting transfer function into ABCD. I have shown you how to do that. So apart from this, if there are a few more things, I will try to incorporate in the my document, and I'll create a document and I'll ask you. Obviously, I'll be mentioning all the steps and I'll be mentioning all the functions and everything, and I'll ask you to execute the experiment number 9. So it will not be taking much time. Like I have asked for experiment 8 also, that is Bode plot and all. It will not be taking much time. Only thing is you have to observe the things and do the analysis. Analysis means not numerical. You have to observe the things, and whatever thing you find, whatever inference you find from that, you have to write in your own language. So in this case, there is nothing to write about it, but I will define all the all your work on experiment number 9 in this. Okay, so with this I'm actually declaring the experiment number 9, and experiment number 10 actually is your coursework. So as a part of coursework, I have asked two MATLAB courses that you have to complete. Those who have completed so far, no problem for them. Your all work is over. You just complete your OBA submission and I think experiment submission. Okay, so experiment 8 and 9 you have to submit up to 2nd of August, and 0 to experiments, sorry, first to experiment 7 you have to submit up to tomorrow. Okay, so there are 9 experiment submission, 2 MATLAB certificate submission, 2 OBA submission, and 2 IA submission. So IA submission everybody has done. OBA submission most probably everybody has done. So only experiments are pending. So try to get it done as soon as possible. Okay, so this codes and clear-cut guideline for experiment number 9, I'll be uploading as soon as possible. By today only, I would like to upload it. So that's all from my side for control systems. If you have any doubt in any of the topics or anything, you can get back, and I would like to answer all your doubts. Okay, so that much from my side at present. Thank you.